Hello YouTube, here I am solving February March 2016 paper 1-2. The reason for that is I just felt like revising my AS chemistry knowledge, and perhaps it will be of benefit to some of you as well. I hope so. So let's start. 9701 March 16 paper 12. Alright, so question number 1. Which compound contains two different elements with identical oxidation states? Alright, so H is +1, oxygen is -2, and Cl will be +1 plus X minus 2 is equals to 0, because overall oxidation state of a compound should be 0, right? So X minus 1 is equals to 0, and that means that X is equals to +1, and so the oxidation state of chlorine is +1. And I've already got the answer here, haven't I? So my answer is A, but you can just check the other options if you want to. -2 +1, that is obviously not the answer. You have +1 here, you have -2 here, and if you want to find the oxidation state of sulfur, so -2 times 4 would be -8, +1 times 2 atoms would be +2, and plus X is equals to 0. So X minus 6 is equals to 0, which means X is equals to +6. Am I right? So this is +6, that means this is not the answer either. And if you want to check out NH4Cl, well, this is what? This is NH4 plus, Cl minus. I can take it separately. So Cl has an oxidation state of -1. H has an oxidation state of +1. If you want to find the oxidation state of nitrogen, I'll just take this NH4 plus. So the oxidation state of this ion is like full ion is +1, right? So let me just take N as X. Okay, so X, and then hydrogen, the hydrogen is obviously has a fixed oxidation state of +1. So +1 times 4 will become +4. I'm just going to take it like +4 is equals to +1, right? So X is equals to +1 minus 4. X is equals to -3. So nitrogen is -3, and none of these are the same. So that means this is also wrong. So my answer is A, as we had already found. Now, second question. For the element sulfur, which pair of ionization energies has the largest difference between them? So let me look at my periodic table. Sulfur is in group 6, or you can say group 16, and period 3. So group 6 means that it has 6 valence electrons, isn't it? So that means the biggest jump should be between the 6th and the 7th, right? Is that an option? That is an option. So that's my answer. That's B. Now the third question. Which ion has both more electrons than protons and more protons than neutrons? All right, so E has to be greater than P, and P has to be greater than N. So for D minus, it's easy to start with the protons, because protons are a fixed number always. So P is equals to 1, and then electron, it has a minus charge, which means it's one more, just -1, so one more electron than protons. So that means A equals to 2, N is equals to 2 minus 1, which is 1. So yeah, N is 1, and since these two are the same, that means more protons than neutrons cannot be true. So that means your A is not your answer, is it? And now look at the second one, H3O plus. So you have 3 protons from H, and then from O you have 8 protons. So your total number of protons is 8 plus 3, which is 11. Then your electrons, you have a plus charge, which means that there's one less electron than protons. So that means your electrons are 10. Neutrons, well, you have no neutrons from 1H, do you? And for oxygen you have 16 minus 8, which becomes 8 neutrons. So you have 8 neutrons in total, and so you have more protons than electrons, but your condition was more electrons than protons. So that means your B cannot be your answer either. Now OD minus, so O has 8 protons, D has 1 proton. So in total, how many protons do you have? 8 plus 1, which is 9, right? And then since it has a minus charge, that means there's one more electron than proton. So your number of electrons is 10 total, number of electrons. And your neutrons, well, O has 8, 16 minus 8 becomes 8, right? So you have 8 neutrons from O, and from D you have 2 minus 1 equals 1. So 1 neutron, so 8 plus 1 is 9. And again, because you have the same number, that means this condition, more protons than neutrons, it's again not satisfied, is it? So you can cross this out as well. And then you have the last one, which probably is the answer, but let us just check. And also, by the way, if I'm making mistakes, please correct me in the comments, because I'm human. I do make mistakes, in fact, all the time. So, you know, better to correct the mistakes so other learners are not confused and stuff. All right. Anyways, O has 8 protons, so that, and H has 1 proton, so 8 plus 1 is 9, so P is equals to 9. All right. And then what? Wait a second. Check this. Yeah, whatever. So then your number of electrons, you have 1 more electron than proton, right? Because minus 1 charge. So that means you have 10 electrons. And then your neutrons are going to be 16 minus 8 is 8. And then you have no neutrons from 1, so that means your neutrons are 8. Does that satisfy the condition? More electrons than protons and more protons than neutrons. Yes, it does. So my answer is D, as we have here. Now, which species contains the smallest number of electrons? Well, B3 plus. Let us see. Boron, according to my periodic table, I'll just keep the periodic table with you guys. Boron has 5 protons, and since it has a plus 3 charge, it means that the number of electrons must be 5 minus 3, which is 2, right? It has 3 less electrons than protons because it has a 3 plus charge. So that means it has 2 electrons, right? Be2 plus has 4 protons, and since it has a 2 plus charge, that means electron equals to 4 minus 2, which is equals to 2 electrons again. And now these two are the same, which means the smallest number of electrons, you know, obviously cannot be A or B then, because they're the same, right? So yeah, and then for H minus, you have 1 proton, and the number of electrons, because it has a minus 1 charge, so that means it has 1 more proton than electrons, so 1 plus 1 equals to 2 electrons. And again, because it's the same, so that means this is also wrong, which means my answer must be D. But let's just check. Helium has 2 protons, and number of electrons, because it has a plus 1 charge, right? So it has 1 less electron than proton, and so 2 minus 1 is equals to 1 electron, and so my answer must be D, right? Next question. Nitric oxide and O and bromine vapor react together according to the following equation. 2NO gaseous plus Br2 gaseous gives 2NO Br gaseous, and your enthalpy change is minus 23 kilojoules per mole, which means it's exo, right? So this reaction has an activation energy of plus 5.4 kilojoules per mole, right? So for exo, that means your overall enthalpy change, like your reactants to your product's arrow, should be downwards because it's exo, and the arrow from reactants to the peak, that should be maybe like this, in fact. So reactants to products, right? So that is downwards arrow, not a double-headed arrow, just a single arrow. And your peak from your reactants to peak, that should be an upwards arrow, obviously, because activation energy is going to be upwards, right? So that is how it should be. And let me see here. So over here, your delta H arrow is going upwards, so C is immediately wrong. Then over here, your delta H arrow is going downwards from the reactants to the product, so makes A a possible candidate. In this part of A is correct at the very least. And delta H over here is going from your peak to the products, which is obviously wrong. It has to go from the reactants to the products. And over here is again reactants to products, so this part of D is also correct. So B and C are out, but A and D are still viable options. Over here, my activation energy is going from my products to my peak, which is wrong. I said from reactants to the peak, right? That's your activation energy. So that means A is also wrong, which means my only possible answer is D, where my activation energy is going from my reactants to the peak, and my delta H arrow is downwards, going from the reactants to the product. So that is right. Okay, and let's go to the next question now. Which series shows molecules in order of increasing bond angle? So CH4, if I just draw it out, carbon has 4 electrons in its valence shell, right? Carbon atom. So you can just draw it out. I don't know if, yeah, I'll just draw it like this, okay? So there's one behind you, there's one towards you, right? Whatever. But since it has 4 electrons and all of them are involved in bonding, it has no lone pairs, so it has 4 sigma bonds, right? So it's steric number. Steric number means number of sigma bonds plus number of lone pairs, right? In the that are involved, like in the valence shell or whatever, right? So that is what makes up your steric number. So carbon has a steric number of 4, which means it must be sp3, right? Must be sp3. You know that. And since there are no lone pairs, so it remains as tetrahedral. So carbon has CH4 has 109.5 degrees, and over here as well I'm going to write 109.5 degrees. Just for my convenience, I'm going to write 109.5 degrees over here as well, so I can compare stuff. Right, now let's go to BF3. Boron is in group what? Group 3. Okay, so boron trifluoride is, I'm just going to draw it like this. It has 3 electrons in its outer shell, boron, and all of them are involved in bonding. So you have 3 sigma bonds, and so your steric number is 3, which means it's sp2, which means it has a bond angle of 120 degrees, and there are no lone pairs, so it remains 120 degrees. Remember that each lone pair reduces the bond angle by approximately 2.5 degrees. So that's how you approximate bond angles. Yeah, so now you look at NH3, which is in group nitrogen is in group 5. All right, so you have yours. Actually, perhaps it would be better if I draw it like this. So you have your wedge here, and you have you could draw this on the other side as well. It's fine. Anyways, you have a lone pair here. So see, you have 5 electrons in the valence shell, and 3 of them are involved in bonding. So you have 3 sigma bonds, and you have 1 lone pair. So your steric number is 4 because 3 sigma bonds and 1 lone pair, right? But it's not. So it's sp3, yes, but its bond angle is not 109.5 degrees. It is 109.5 degrees minus 2.5 degrees because of that 1 lone pair. So it becomes 107 degrees. All right. So your bond angle here is 107 degrees. And do you have any other NH3s? Yes, I'm going to label these as well. Right. So that is for NH3, you have a bond angle of 107. Next, I have H2O over here. H2O, if I just draw it out, it's like this. NH3 was, by the way, the shapes, this is called trigonal. BF3 was trigonal pyramidal, CH4 tetrahedral, and NH3 just pyramidal. Sorry, I'm so sorry. BF3 is trigonal planar. I don't know why I said pyramidal, just came out of my mouth, but BF3 is trigonal planar, all right? Planar, trigonal planar. And NH3 is pyramidal. And H2O, we call it, you can call it bent, you can call it V-shaped. I prefer V-shaped, but you can call it bent as well. It's not a big deal. All right. Yeah. So anyways, the oxygen, it has 6 electrons in its valence shell. There are 2 lone pairs and 2 bonding electrons. So you have 2 sigma bonds and 2 lone pairs. 2 sigma bonds and 2 lone pairs mean that the steric number is still 4. But your bond angle is reduced by like 2.5 times 2 is 5, right? So your bond, because you have 2 lone pairs, so your bond angle reduces by 5. So 109.5 minus 5 becomes 104.5. So your bond angle here is 104.5 degrees approximately, of course, but yeah, 104.5 degrees. So next, the one I have left is CO2. Let's see. So OCO, right? And carbon again has 4 electrons in its valence shell, and all 4 of them are involved in bonding again. You have 2 sigma bonds and 2 pi bonds, but remember, pi bonds are not included in your steric number calculations. So you will not count these, and because there are only 2 sigma bonds and you don't have any lone pairs or anything, so that means your see, I think sigma should be written like this, but I just read like this. Maybe I should make my writing clearer. Anyways, 2 sigma bonds, right? So since you have 2 sigma bonds, that means your steric number is 2, which means you have a sp configuration, right? So sp means that it's 180 degrees, which means it's linear. So this is 180 degrees, and this is also 180 degrees, all right? So now that I've written all the bond angles, if you have in the exam, if you've just gotten some and you can eliminate options, that's good, but I'm doing it for explanation, so I'm taking my time. So I'm starting with D. This is increasing bond angle, but then this is decreasing, so that means D is wrong. This is increasing bond angle order, so I would say my answer is C. This is increasing bond angle, but then this is decreasing, so that means B is not the answer. This is increasing bond angle, but then this is decreasing, so that means A is not my answer either. So C is my answer. That's the answer, right? Question number 7. What is the volume of steam produced when 1 gram of ice is heated to 223 degrees Celsius at a pressure of 101 kilopascals? So for this, I'll use my beautiful equation P equals nRT. In fact, in A2 physics, you learn that there's another equation you can use, because this is N here represents the number of moles, right? But you have another equation which is PV equals NKT, and over here it represents the number of molecules, and K over here is your Boltzmann constant, 1.38 into 10 to the power minus 23, if I'm not mistaken. And by the way, I would like to mention one thing. Temperature, when you represent temperature with a capital T, it means your thermodynamic temperature, or temperature in Kelvin. When temperature is represented in theta, that means your temperature in degrees Celsius. All right, and if it's delta T or delta theta, that it doesn't make a difference if your unit is Kelvin or degrees Celsius, because you're just calculating the difference in temperature. So it doesn't matter if your units are Kelvin or Celsius. But for T you should have it as Kelvin, and for theta you should have it in degrees Celsius. So over here my temperature should be in degrees Celsius. Sorry, Kelvin. That's what I'm trying to say. So anyways, I want to find the volume, so I'll rearrange it as nRT over P. And since I do not know the moles, but I know the mass, and it's ice, so I know that H2O has an MR of 16, which is for oxygen, plus 1 times 2, which is hydrogen. So 16 plus 2 is 18, so it has an MR of 18, right? So that I know as well. So I can just rearrange this as an M over MR for the moles. I can rewrite because N equals M over MR, right? So I can put that in my equation, and then R times T, and then P. So I can rewrite this as MRT over MRP, all right? So that I just rewrote that. And now if you want, you can calculate the moles separately and then put that value into the equation, but I prefer to just add variables to the equation, instead of and calculate it all out in the end rather than calculating it like that. So the value in the data booklet, I think, is 8.31. If you want to be more precise, make it 8.314. It doesn't really matter for paper 1, but yeah. Then 323, again, I'm going to convert it to Kelvin, so I'm going to make it 323 plus 273, because 0 degrees Celsius is equals to 273 kelvins, right? That's why. Approximately. Yeah, so MR of water, again, as I mentioned, is 18, and then times your pressure, which is 101 kilopascals, 101 times 10 to the power of 3. It's very important to remember to convert things, right? And so just put this in your calculator, input all that into your calculator, and you should get you get your answer in meters cube. But if you want to convert from meters cube to dm cube, then you have to, because you see deci means 10 to the power of minus 1, right? So if you want to convert so 10 to the power of minus 1 meter cube. So what I mean to say is, if you're converting from deci to meters, then you would have to multiply by 10 to the power of minus 3, all right? And if you're converting from meters to decimeters cubed, then you have to multiply by 10 to the power of 3, because decimeter cubed is basically the same as saying 10 to the power of minus 1 cubed meters cubed, which means it's 10 to the power of minus 3 meters cubed, right? So dm cubed to meter cubed, the conversion is 10 to the power of minus 3, and meter cubed to dm cubed, the conversion is the opposite, which is 10 to the power of 3, all right? So over here I want to convert from meter cube to dm cube, because all my answers are given, like my options A, B, C, D are in dm cube. So I will multiply this by 10 to the power of 3, which means this cancels with this. But since I've already calculated out of my calculator, I'll just manually multiply by 10 to the power of 3, and that gives me approximately 2.7 dm cube, because my options are also in 2 significant figures, so I'll just take it 2 significant figures, and my answer is C, therefore. So yeah. Next question. Silicon carbon dioxide, CO2, is similar to solid iodine, I2, in structure and properties. Carbon is in group 14. Silica, SiO2, is a group 14 compound. Which statement about solid CO2 and solid SiO2 is correct? Let's see. Both solids exist in a lattice structure. Well, they're solids after all, so obviously they exist in lattice structures. My answer is A, done. But let's just check the other options as well. Both solids have a simple molecular structure. No, they don't, because solid SiO2 is a giant covalent macromolecule, isn't it? And both, let's see the next option, both solids have atoms joined by single covalent bonds. Well, as I recall, we did it just in the previous question, previous question, I mean. See that the structure of this is OCO, right? So those are double bonds. So no, it's not single covalent bonds, but for both solids. Both solids change spontaneously to gas at STP. Now, carbon dioxide does sublime. This is, a spontaneous change from solid to gas, or from gas to solid, is called sublimation, and that does happen for carbon dioxide. But you have to remember that SiO2 is a giant covalent macromolecule. It's not that easy to make it change state. So this is obviously wrong. And so your answer is A. All right. So next question. An article in a science magazine contains the following statement. It is lighter than a feather, stronger than steel, yet incredibly flexible and more conductive than copper. Now the good thing about not the good thing, but like the thing I like about chemistry is that it's a perfect balance of, mathematical knowledge as well as memorization, theory and practical. Like it has a good balance of a lot of different things. Some things you just have to know, sadly. This is obviously the description of graphene. You should know that, and so your answer is C. It cannot be graphite. It cannot be diamond either. Like think of it lighter than a feather. No, that's not diamond. Buckminster fullerene. It's not Buckminster fullerene either. It's graphene, and you should just know that. All right. And yeah, I do not know much what else to say about that. Which equation has an enthalpy change of reaction which corresponds to the standard enthalpy change of atomization of chlorine? Well, let's construct the equation. So standard enthalpy change of atomization of chlorine means I'm forming a chlorine atom in the gaseous state at the end, right? And I'm just forming one atom. So that is what atomization implies. And what am I forming it from? Under standard conditions, obviously, I'm forming it from its element that exists in its standard state, right? So that is Cl2 gaseous, but since I'm forming one atom, so I make it 1 by 2 Cl2 gaseous. So 1 by 2 into 2 becomes 1, right? So 1 here. Right, so that's how to balance the equation. And so I just have to see which one matches with that. Now these two are wrong because they have liquid, so that's wrong. And over here I'm forming 2Cl, which is wrong. But this is exactly a match to what I have written, it's a perfect match. So that means my answer is A, right? Next question. Yes, Casey. I love equilibrium things. Anyways, well, it depends, because some equilibrium things are not good, such as climate change. Climate change is not an equilibrium thing I enjoy. Anyways, in an experiment, 2 moles of hydrogen and 3 moles of iodine were heated together in a sealed container and allowed to reach equilibrium at a fixed temperature. The container had a fixed volume of 1 decimeter cubed. At equilibrium, there were 2.4 moles of iodine present in the mixture. Alright, so let's write this down. You can make a proper ice table, but this is paper 1. I'm just going to write it as 2.00, 3.00, 0.00, that's all. And obviously for paper 2 you should be neater and all, right? Now in the end you have 2.4. Now the thing I want to mention here is I just write it down in the corner. So how would you write down Kc over here, right? So it will be hi squared over h2 into I2, right? So you have to realize that over here, like I have 2 moles on this side and 2 moles on this side. So like for example, x squared divided by x into x. I'm sorry that my x's are so bad. My friend even told me to make curly x's so that they're more differentiable from multiplication sign. But yeah. Anyways, maybe x square over x square, right? So then you just, what I mean to say is that in this calculation, your units first of all cancel out, because mole per cubic decimeter on the top, that is squared, and on the bottom as well, mole per cubic decimeter is squared, right? So your units cancel out. And on the same vein, because you see they have mentioned that your volume is 1 cubic decimeter, right? So even if they're not mentioned volume, it will be fine. Why? Because think of it as I have a concentration of x over v. Okay, so this is my moles, and or let me just make it n, because we're used to seeing moles as n, right? So n1 over v squared over n2 over v times n3 over v. All right, so that makes it better. And in fact, you should use square brackets. And so it becomes n1 over v, the whole squared. And you see, because this is v square and this is also v square, right? So all the v's actually end up cancelling out. And so you don't need the volume actually. So like if it was paper 2, it would be good if you write down 2.00 over 1.00 and then you show that. Or if it is given a volume of v, so you just write down v and you show that. But since it's paper 1, I'm not even going to bother doing that, because volume anyways cancels out. I don't need to do that. It's irrelevant. It's not necessary. So this and then there are 2.40 moles of iodine present in the mixture. So I'll write down 2.40 here. Now how much is this decreasing, guys? So 3 minus 2.40 is a decrease of 0.60 moles per cubic decimeter, I can say in fact. But you can also say talk about moles or mole per cubic decimeter. It doesn't make a difference because your volume is 1 decimeter cube first of all, and your units cancel out, so it doesn't really matter too much in this discussion. So that happens. Now since this is a 1:1 molar ratio, right, so this will also decrease by minus 0.60, and so 2 minus 0.60 should be 1.40. So this is equilibrium moles for this, or you could say the equilibrium concentration is fine. But this is 1:2 molar ratio, right? So this means this will increase first of all because it's on the other side of the equation, and 0.6 times 2 is 1.2, so plus 1.20. So this becomes plus 1.20. We can just say 1.20 in fact. So the equilibrium moles for this are 1.20. So now if I want to find Kc will be 1.20 squared. Now I'm using square brackets. The reason behind using the square brackets is because the standard chemistry convention is that square brackets represent concentrations, and we're talking about concentrations. So yeah, you can write down V here, or if you don't want to write down V, don't write it because it's paper 1 first of all, and V cancels out. Okay, but paper 2 I would go the extra mile and show the working, honestly. But with paper 1 I'm just not bothering. Just calculate this out, and it ends up being approximately 0.429, and so my answer is C. Alright, so let me just redo it because you never know, you might make a mistake, and I'm getting 0.4 again, so that should be my answer. And next question. Consecutive elements X, Y, and Z are in period 3 the priority 1. Now for period questions are like, questions like these, I just like to write down, the relevant group or the relevant period. Because it just makes things easier for me. Sodium, magnesium, aluminium, silicon, phosphorus, chlorine, argon. I have it memorized because I've just used period 3 so much, but I would say it's worthwhile to memorize a few things. It just makes your paper solving quicker, faster. So anyways, they're consecutive elements, which means one after the other. Element Y has the highest first ionization energy and the lowest melting point of these 3 elements. So these are X, Y, and Z. I'm just going to divide this up. So let me just talk about lowest melting point. I feel like that would be easier to identify. Lowest melting point, right? So sodium, magnesium, and aluminium. Y does not have the lowest melting point. Aluminium has the lower melting point. Has a lower melting point than magnesium, right? Obviously, so that means this is wrong immediately. And then magnesium, aluminium, silicon. Silicon obviously has a much higher melting point than magnesium, aluminium, so I'm going to cross this out as well. Aluminium, silicon, phosphorus. Now again, silicon has the highest melting point ever. So wait, in fact, silicon has the I mean not the highest melting point ever in the world, but like a higher melting point than aluminium and phosphorus. So that means this is wrong as well. So my answer must be D, but let's check it out. Silicon, phosphorus, sulfur. This is P4, this is S8, and so obviously P4 has less electrons than S8, so S8 will have stronger valence forces, which means a higher melting point. Silicon is a giant macromolecular structure, so it obviously has a higher melting point, but then P4 is the lowest melting point compared to out of silicon, phosphorus, and sulfur. So that's the first tick done. And then highest first ionization energy. Highest first ionization energy. That is an interesting one. Should I think about it in terms of trends? Well, I don't know how to go about this. Me personally, I because this is March 16, paper 12, right? So they haven't. The data booklet was still in use, right? Because now 2022 they don't provide the data booklet anymore, but that time they used to provide the data booklet. So I would personally just look at data booklet and check what the values are. So silicon, its first ionization energy is plus 786. In fact, even at AS level, I would recommend you to have data booklet because it's quite useful. Most of the past paper questions, they are before 2022, so they're still in use. So you can use it, but just don't be too reliant on it at AS because it's good to see trends, but then you will be provided the data booklet in your test. Is the problem. However, it's a very useful tool and I love it. Another data booklet is quite a treasure trove of information, so to speak. So yes, phosphorus does have the highest first ionization energy, which makes the correct answer. And yeah, maybe there's a way to look at it through just qualitatively through periodicity, but I personally cannot think of it right now. I don't know. I really can't think right now. So yeah, plus one. I don't. I can't think right now. So like yeah. Anyways, let's B. Now, when dealing with the spillage of metallic sodium, it is important that no toxic or flammable products are formed. Which materials should we use if there is a spillage of metallic sodium? So, dilute hydrochloric acid. Let us write down the equations, okay? Na plus HCl gives you NaCl plus 1 by 2 H2, right? So, H2 is quite a flammable product, isn't it? So, that means this must be wrong. Ethanol, again, because it's a sodium reacting with an acid, so you're gonna get the same thing fundamentally, CH3COONA plus half H2. Again, you get flammable hydrogen, so that is wrong. Sand is mainly SiO2, right? Quartz, silicon dioxide. So, like what was supposed the reaction going to be? I literally don't remember the reaction. It's been a long time since I've studied AS. Let me just look at my notes. Embarrassing. The fact that I don't remember this reaction is quite embarrassing, but it's okay. Or let's just look at it on the internet, because the internet is true than SiO2 plus Na reaction. Not YouTube, Google. So they haven't given me that reaction actually. Does that mean that SiO2 does not react with Na? Could be, because SiO2 is a giant well-natural molecule that doesn't react with everything in the world, and I wouldn't expect it. I mean, again, silica is slightly acidic in nature, and so is capable to react with the base, right? So SiO2 reacts with NaOH because it's slightly acidic, but with Na, would you expect it to react? I don't know. But let's look at water spray, which means H2O. Na plus H2O gives you, again, because I don't know everything, and if you know the answer, like if you know the reaction or whether there's no reaction occurs, that's great. I just can't remember it right now. So the good thing about paper 1 is that you can just eliminate options and get to the right answer that way. But obviously for paper 2, paper 4, etc., you would need to have your knowledge very, very solid and stuff. Yeah. But this is the reaction you have with water spray, and that gives you flammable hydrogen as well, so that's wrong. So that means my only option possible is sand, isn't it? SiO2 plus Na. I don't know if there's any reaction. I'm not able to find any reaction for that on the internet, so whatever, but you get the point. The answer is sand. Perhaps there is no reaction between Na and SiO2. I really don't remember. I really can't find the answer in my I have a feeling that it does not react with sodium. Personally, I feel that that's the answer. Because it doesn't react with a lot of things, does it? It is a giant macromolecule. I'm just going to assume that, and yeah, it's just some things are better assumed. Yeah. Anyways, let's go to the next question. Chlorine gas is widely used to treat contaminated water. Which species present in water when chlorine gas has been added is responsible for killing bacteria? So let me see. You have sorry, what am I doing? H2O plus Cl2 gives you HCl plus HClO, right? So this HClO is the thing, really, and then HClO, it further decomposes into HCl and O, right? So that is the way it is, and since you get oxygen free radical, that is what causes bacteria to be killed. So this HClO can be, you can write it as H plus and ClO minus. So ClO minus is wrong, Cl minus is wrong, HCl is wrong, and OCl minus is the right answer, as I showed here. H plus ClO minus. So or you can rewrite it as H plus plus ClO minus, which is H plus plus ClO, whatever, but fundamental thing I have showed here is H and ClO minus. Alright, so the answer is D. Which row of the table is correct? Ammonia molecule. Now, as I mentioned in one of the previous questions, ammonia NH3 is pyramidal in shape, right? This NH3 is the lone pair. So 1, 2, 3, 4. Its steric number is 4 because it has 3 sigma bonds and 1 lone pair. That makes the steric number as 4, and so it has sp3 hybridization. But since it has 1 lone pair, so its bond angle is 109.5 minus 2.5, which means 107 degrees, right? Means it's pyramidal. And ammonia molecule has only sigma bonds, as you can see here. No double bonds, no pi bonds, no double triple bonds, obviously. And then for the ammonium ion, what's happening is that this lone pair, basically, it's being donated to a proton, an H plus, right? So you get an H4 plus, right? So NH3 plus H plus gives you an H4 plus. And the thing about chemical equations is that they should be balanced in terms of the number of atoms as well as charges. So you can see that there's a +1 in this left hand side, so there should be a +1 on the right hand side as well, which is why we put the plus, right? Obviously, that's the easy way to think about it. And yeah, so since H plus has no electrons, right, so you're donating 2 electrons to it, and you get a leaded covalent bond. So yeah, and now you have 5 bonding electrons or whatever. Sorry. You have 1, 2, 3, 4 bond pairs, right? Since you have 4 bond pairs, what you're getting is a steric number of 4, still a steric number of 4, because you have there you had 3 bond pairs and 1 lone pair. Here you have 4 bond pairs, so steric number is still 4, so it's sp3, but there are no lone pairs, so it's 109.5 degrees, which means it's regular tetrahedral. And again, you cannot see any double bonds or triple bonds, so there's no pi bond, so it's just sigma, 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 and so your answer is A. Great. Question number 16. Hydrogen fluoride gas and hydrogen iodide gas have different thermal stabilities. The difference is due to difference in the energies of some of the covalent bonds that are involved in the decomposition, which row identifies the more stable of the two compounds and give the correct definition. So let me just start with fluorine, bromine, iodine, astatine. Why not include fluorine as well, because he's also part of the group. Yeah. So yeah. Now, explanation for the difference in stability. Why would I mention ClClII? Why would I mention ClClII? I'm going to cross that out. Identity of the more thermally stable compound. Well, down group 17, your atomic size increases, right? The size of the halogen atom increases, which means that your, because your H is going to remain the same, but then your orbital overlap decreases down the group, means you get a longer and longer bond length, right? Because bond length is the distance from the distance between, like, from one nucleus to the other nucleus when you're talking about the two nuclei that are bonded together, right? So your bond length is getting longer, so that means your bond is getting weaker, right? Because as your bond length gets longer, your bond gets weaker. So that means that my stronger from fluorine to iodine, because my HI has a longer bond length, so it's the weaker one. So it's the less thermally stable one. It breaks more easily. So HCl is the more thermally stable one, right? So HCl is my more thermally stable one, as I just explained. And the explanation is that HCl's bond is stronger than the HI bond. So my answer is great. Yeah. Absolutely amazing. Now, ammonium sulfate, NH4 twice SO4, and ammonium nitrate, NH4 NO3, are used as fertilizers. These salts have different percentages by mass of nitrogen. They have the same effect as each other on the pH of neutral soil. Which row is correct? Well, both of them contain NH4 plus, do they not? NH4 plus, but like NH3, it's a base, right? NH3 is a base, which means NH4 plus obviously is an acid, because this is the Brownstein-Lowry acid-base theory, isn't it? That every base is a conjugated acid and every acid is a conjugate base. So yeah, according to that, NH4 plus is an acid, isn't it? So because it's an acid, that means it lowers the pH of the soil, i.e. it makes it more acidic. So effect on pH of soil should be decreased, and Now let's check out which of these has a higher percentage of nitrogen by mass. For that, first let's find out the so my thought process for this basically is that firstly let's talk about NH4 twice SO4. So what I'm supposed to do is find out, so it has two nitrogen atoms, right? So each nitrogen atom has an AR of 14, right? So 14 times 2 would be 28.0. So 2 nitrogen atoms is 28.0, that's what I mean. If I find the MR of the whole molecule, that would be 28 plus 4 to the 8. So for hydrogen fully you have 8, and then SS1, so that's 32.1, and then 16 times 4 for oxygen, so that gives me 132.1. And also this is a percentage, I have to multiply by 100. So 28 over 132.1 times 100 gives me approximately to three significant figures, 21.2%. All right, 21.2% for NH4 to S twice SO4. If we talk about NH4NO3, the percentage by mass of nitrogen will be the same way because it has two nitrogen atoms, so 28.0, and if we find the MR of the whole compound, so 28 plus 4 hydrogen atoms of 4, and then 16 times 3 for oxygens, and it's 80.0 is the MR, so 80.0 times 100 plus percentage, so that's approximately 28 over 80 times 200. That's not approximately, in fact exactly 35, and I'm just going to add 0.0% for good measure. So that's 35.0, so which has a greater percentage of mass of nitrogen? That is NH4NO3, is it not? This is lower, this is higher, so that means NH4NO3, so that means ammonium nitrate. And so my answer is A. Done. Now, river water in a chalky agricultural area contains Ca2 plus Mg2 plus CO2 minus, CO3 minus, Cl minus, and NO3 minus ions. In a water treatment plant, such water is treated by adding a calculated quantity of calcium hydroxide. What would be precipitated from the river water following the addition of calcium hydroxide? So CaCO2, will that be precipitated? No. CaCO2 is soluble in water, so no. CaCO3 is not soluble in water, so that would be answered. CaNO3 twice, all nitrates, and MgNO3 twice. Remember that all nitrates are soluble in water, so that is obviously not the answer. They're all aqueous, so then the answer is B. That's it. Pretty simple question actually. And yeah, that's all we have to do in this question. 19. After black and white photographic film has been developed, unreacted silver bromide is removed by reaction with sodium thiosulfate. What is the function of the thiosulfate ion? To make the silver ion soluble, to oxidize silver ions, to reduce the bromine, to reduce the silver ions. But for these three options, I would have to have a redox change, right? But if I look at this, +1, +1, -1, -1. So there's literally no redox reaction happening here, which means that immediately my option B, C, and D are out, and my answer is A. Done. To make the silver ion soluble, because I use elimination to find out that these three are wrong, so that means my answer must be to make the silver ions soluble. And if you see here, silver bromide, we know from our practicals, hopefully you guys have done some paper 3 by now, you must have learned that AgPr is a precipitated solid, and then over here you have AgS2O32 3 minus, which I can just assume to be a soluble thing, right? It seems like a soluble thing to me, and so that means to make the silver ion soluble seems to be the right option. Okay, question number 20. Yeah, we're at organic chemistry, pretty nice. People who take statin drugs, I've heard of statin before, although I have not taken biology since grade 10, but I remember doing statin. People who take statin drugs to control their blood cholesterol may also take coenzyme Q10. Now that's one I have not heard of. Yeah, so maybe bio people know about it. Diagram shows a simplified structure of one form of this coenzyme. Which row describes this structure correctly? The coenzyme is an aldehyde or a ketone. Well, I do not see any aldehyde groups. I do, however, see 2 ketone groups, so I will go with ketone. And the number of pi bonds in one molecule, well, let me see, I've got 1, 2 pi bonds, then 3, 4, 5. So I've got 5 pi bonds, and since I have n, so that means n plus 4, right? Because 1 is already included, like n, and then n plus 1, n plus 2, n plus 3, n plus 4. So that means n plus 4. And so my answer is D. Done. 21. Geraniol and nerol are compounds found in some flower fragrances, and might I say those are pretty cool names. They're isomers of each other. Okay. Now, which type of isomerism is shown here? So CH3, CH3, CH2, CH. I do not see any difference in these two parts. nor do I see any difference over here. But if I look here, these two groups are reversed, aren't they? So that means that it probably is cis-trans isomerism, because that's the definition of cis-trans isomerism, right? There's a double bond, and there are two different carbon atoms attached on this one carbon atom, the double bond, aren't there? So that means it's cis-trans isomerism, quite obviously, or you can call it easy isomerism, whatever. But yeah, geometrical isomerism, whatever you want to call it, but you get the point. It's cis-trans. So a section showing two repeat units of an addition polymer is shown. What is the identity of the monomer that produces polymer? So let's draw it out. For drawing the monomer, we just cancel out these two single bonds and remake the double bonds. So that is the monomer that we have. And if I look at this monomer, then I have my longest carbon chain is 4 atoms, right? So it has to be a butene something. So pentene is immediately wrong, hexane is immediately wrong, and butane again is immediately wrong because I have a double bond, so it means there has to be an ene. So that makes my answer immediately as B. If I check it out, it is literally 2-chloro, 3-methyl, but 2-ene, because the double bond is on the second carbon atom, right? So that is right, and so my answer is B. 23. But-2-ene 1,4-diol is converted in 2 steps through an intermediate X into oxobutane dioic acid. Now, me personally, I love drawing skeletal formulas, so I'll just draw my skeletal formula out. So I have a 4-carbon chain here, and yeah, just make this bigger. I have a 4-carbon chain with sorry, what did I do? Then I have an OH here. I have an OH here, and I have a double bond here, right? So that is my structure of but-2-ene 1,4-diol, and then this is getting converted to some X, which is getting converted to oxobutane dioic acid, which again would have 4 carbon atoms, a COOH here, and a COOH here, and a C ketone group here, alright? So that is also butane dioic acid, and this is formed by hot acidified KMnO4. So what could be the reagent for step 1, and what is the intermediate X? Okay, look at the first option. So what do they have? What have they drawn X as? They have drawn X as this random thing, I suppose. I don't exactly get, like, hot acidified KMnO4. I don't really get what they're trying to do there. I mean, I do think let me just check with it, and if I can acidified KMnO4 affect which that's oxalic acid. I feel like I don't exactly remember, but hot acidified KMnO4, I think it won't do anything to this thing, but it will be able to affect the end ones, or either it's either that or the reverse of it. I don't exactly remember, but I think it will affect the end ones, but not this one, or something like that. I don't exactly remember. I'll just check if I've written my past self. Past. Was she smart enough to write notes on this, or was she not? I don't know whether I trust her, Check. She wasn't smart enough to do that. And I'm disappointed at her for that, but whatever. I forgive her. Nevertheless, you can check that in your free time. But the point is, was it Can't have been. But I don't exactly remember this thing. But my point, if any of you know, kindly write it down in the comments, or if I remember, I'll mention in the comments later. But the point is that it can't do this. It can't make this product because it cannot oxidate. Like hot concentrated KMnO4 is not successful at oxidizing this into this. So A is not the answer. All right, that's my point. Now for B, they've used hot acidified K2Cr2O7 to make this. So I don't know what that is. Let's look at it. It is this compound. Now the problem with hot acidified K2Cr2O7, it will not be able to do this business here. It will not be able to do that. So hot acidified K2Cr2O7 will not be our answer. I mean, so that B is not our answer either, and not to mention that when you have this C, so then hot acidified KMnO4 will just rupture this, won't it? Then you get two thingies. You won't get this product, oxobutane dioic acid. Honestly, this is just teaching me that I should really revise my AS organic chemistry. Yeah, so I have to do that. Now there's another thing on my bucket list, right? Or I don't know whether to call it a bucket list or not, but you get the point. And then steam and concentrated H2SO4. Well, since it's steam, so H2O, and concentrated H2SO4 probably just acts as a catalyst or something. So I'm just adding water basically, or something like that. I think so. Very easy. I think that's the reaction that's going on, and that really does seem reasonable to me. And polysaccharide KMnO4 will. Oh, okay. So, now I'm confused. Oh, okay. How? So apparently, in fact, let me just, because I don't want to spread misinformation, so I will just check the scheme for this question. And the answer is C, alright? So the answer is C, which means that if I have this product, I have the same product in A and in C. So that means that hot acidified KMnO4 is successful in making this, alright? So that is one thing that is apparently true. That hot acidified KMnO4 will oxidize this and this. It's quite a strong oxidizing agent in that case. So that's one thing, and that means that for A, the problem with A was that it's cold acidified KMnO4. The problem was not with X. The problem with cold acidified KMnO4 means that this thing should actually have become a diol, right? So that is what it should have become, and that was the problem with A. So that's why A was wrong, because the intermediate X was incorrectly drawn. So that is the problem with A. Alright. So that's the problem, and with warm acidified K2Cr2O7 again. That's wrong. CO2 OH, like, yeah, what is that? You know, why do you have a random OH here? I don't know. I don't get the logic, so that means D is wrong as well. But C is the right answer for that. Quite a tricky question, actually. I have to admit, this one for me at the very least. But yeah, the answer is C. You just have to really know your reactions very well for this question, I feel. Or maybe I have to revise my organic chemistry personally, I don't know. But anyways, the answer is C. Now, 24. Hydrogen bromide can be added to T to give compound U. Compound U can be hydrolyzed to compound B. 4 students W, X, Y, and Z made the following statements. All the atoms in a molecule of compound T lie in the same plane. Well, that is, I can immediately tell that's not right, because this is sp3, this is sp3, this is sp3. sp3, what does that mean? 109.5 degrees. And how do you draw 109.5 degrees? For example, if I draw CH4, This is how you draw CH4, is it not? So wedge means towards you, dotted line means away from you. And what does that mean? It means it's a 3D thing where they're all not in the same plane, basically. And so immediately I can tell that T is wrong. If you have a model of a sp3 molecule, that would be great, but I don't. But you know, yeah, basically, yeah. And compound B contains only one chiral center. Well, compound B actually, look at this, look at this, look at this. This is 2 chiral centers. Is it not 2 chiral centers? It is 2 chiral centers. So X is also wrong, which means W and Y option is wrong, W and Z option is wrong, X and Y option is wrong. Y and Z option is right. Step 1 is an electrophilic addition reaction. That's right, because this is a double bond and you're adding a hydrogen and a Br to that. So that is right. Yes, that is right. Step 2 is the nucleophilic substitution, right? That's because you're right, because you're substituting one nucleophile for the other. So that is right. So Y and Z are right. Good job. D is your answer here. And let's go to the next question. Structural isomerism and stereoisomerism should be considered in answering this question. Compound J is reacted with KOH dissolved in ethanol. So it's not KOH or KOH dissolved in water, right? Or aqueous KOH. So that means you're not doing nucleophilic substitution. You are doing, I don't know what to call it, elimination, perhaps, or alkylation. I'll just call it elimination. That sounds more proper, although I prefer alkylation because it just makes sense in my brain. But anyways, elimination. 3-isomeric alkene is a molecular formula C4H8 form. What is D? So you're basically going to lose this Br and you're going to lose an H over here, and so the bond that's broken here, you're going to form another bond with another carbon another carbon that is adjacent, right? So adjacent to this carbon, basically. So adjacent to this carbon, you only have one carbon. So that means you only get, so if I just draw it skeletally, because I find it easier to draw, you know, imagine things skeletally, but you know, every person is different. So this is only, it won't have any, it's just one, you know, you don't get any of the isomers from this. This is wrong. Now, if I remove this Br, then I have 2 adjacent carbons here, right? So I can either get this attached here, which means I get this thing, same as here, same as the thing I got here, or I can attach it to this carbon, right? So that means that I get but2ene, which will have cis trans, so that is the trans version, and this is the cis version of it. So that means I think B should be the answer, but let us check the other options as well. So I eliminate this, and it gets connected. The only carbon atom that is adjacent to this one is this one. So I get, is that 4 or 5 bonds? That is 5 bonds. So the C gets eliminated because 1, 2, 3, 4. All right, and that gets eliminated. And so I get what? What do I get? I get methyl propene, which is a branched isomer of C4H8, right? The only branched isomer of C4H8 actually. And that's all I get. I don't get any other thing. And if I eliminate this, I have 3 adjacent carbon atoms. The thing is, all 3 of them are methyl groups, all 3 of them are identical, so attaching it to one of them is the same. I would get the same thing I would get attaching it to any of the other 2. So actually I get the same thing, which is methyl propene. Wow. So that means, you know, yeah, so I only get 1 isomer here, one isomer in C and D as well. So my answer has to be B, where I get 3 isomers, and they said 3 isomeric alkenes, right? So my answer has to be B. Alright? Next question. Which row correctly shows a primary, a secondary, and a tertiary alcohol? So over here I have a carbon with an OH attached, right? And now to this carbon I have 1 atom attached directly. So that means it's a primary alcohol. So that is right. Over here again I only have 1 atom, so this is primary as well. Over here I have 1 atom directly attached again, so that's primary alcohol. And over here to this carbon atom I have 1 carbon atom attached directly, so that is again a primary alcohol. Now if I look at my other options, sorry, so till now it's any of the options could be right, but I don't know. Let's check secondary option. So over here, this has two carbon atoms attached. This could be considered to be secondary alcohol. If you look at it from that direction, then it's not. But I can take this. Yeah. Well, this one, it has 3 attached, so it's tertiary alcohol, which means it's wrong. So B is out. Over here, if I look at this carbon atom or this carbon atom, both of them have only 1 carbon atom directly attached. So that means it's a primary alcohol, which means it's wrong. And over here, this carbon atom which has 2 carbon atoms attached to it, so that is secondary, directly attached. And over here, if I take this one, it has 2 atoms attached, so you can take it as secondary. Or if you look at these two, then it's this one is attached to 1, this one attached to 1, so it's secondary or primary. So this is wrong anyways, no matter what it is, but it's wrong. Over here I have so why am I looking at this one? I should be looking at this one because this is one that's attached to the OH. If I look, it's directly attached to 1 carbon atom, so it's primary, so that's wrong. If I look at this one, it's attached to 1, so it's primary. I look at this one, it's attached to 1, so it's primary. Look at this one, it's attached to 1, so it's primary. So this is a primary alcohol. It's wrong. And over here, this OH is attached to 3 carbon atoms directly. So the one that's connected to OH is attached to 3 carbon atoms directly. So it is a tertiary alcohol, which means it's right. Okay, so that means my answer has to be D, right? Because all the other options are eliminated. So yeah. 27. The fragrance compounds of perfumes are often dissolved in solvent Y, which has a molecular formula C7H12O4. It is made by reacting propane 1,2-diol, which is this thing, with ethanoic acid in the presence of an acid catalyst. If I just draw out ethanoic acid, CH3COOH. Alright. Now, ethanoic acid in the presence of an acid catalyst. So what is happening is that you're reacting at a diol with an oic acid, which means you're going to have esterification taking place, right? And in the presence of an acid catalyst, so obviously there's esterification. What happens in esterification is that your oic acid, your carboxylic acid, it loses its OH, and your alcohol, it loses its H, right? So that's what I'm going to do. I'm just going to annotate on this diagram and make I need to form an OCO bond basically, right? OCO. So that's what I'm going to do. I'm going to remove this H here and attach a CO, and since ethanoic acid has 2 carbon atoms, so I'm going to attach another one and make it like this, CH3, alright? So that is what my thing is going to look like from that side, and on the other side I'm going to do the same thing, obviously. Just gonna remove the O, make it a CO, so I got a OCO, and then because it's ethanoic acid, so it has 2 carbon atoms there, so it's CH3. Alright, so that's the structure I should be looking for, and let me see. So this part should remain unchanged, and that's the case in all 4 of them. And then these 2 carbon atoms of the propane 1,2-diol, they should be directly attached to 2 O's, 1 O here, 1 O here. That is not the case in A, because C here, this is a C, this is an O. Over here, again, I have a C and an O, so that is wrong. Over here, I have an O and an O, so it could be right. And over here, I have a C and a C, so that is wrong. So immediately my answer is D, but if I just check it out, I have OCO and then CH3 attached, OCO and CH3 attached. So D is definitely the right answer, and it directly matches with the structure I got there. Up. So my answer is D. Which mixture could be used to produce propyl methanoate? So what is propyl methanoate? This is my alcohol part, this is my ethanoic acid part. So if I draw out propyl methanoate, again I'm going to draw it out as a skeletal formula because I like skeletal formula. So this is my alcohol bit, and then I have an O, and then I have, it's wrong, I'll start with my, I don't know if it's wrong, I'm just going to start with my methanoate. I feel like, why is not my brain working? I don't know. Why is my brain not working? That's what I meant. So 1, 2, 3 carbon atoms for the propyl, and then you have an O, and then you have a C, and then you have an O. That is how it is. I don't know why it took me so long to do that. I'm right about that. I think I should be right because then yeah. So that breaks down, and you get an OH. This is your methanoic acid. If you break it down, you get methanoic acid, and on the other side you get OH. Alright, so that is the way it is. So I should be looking at for propanol firstly, and so let me see, 1, 2, 3, 4, 4. No, I that's COOH anyways. 1, 2, 3, propanol. That is propanol. That is right. 1, 2, 3, 4. I don't need butanol. 1, 2, 3. That's an acid. So no, that's wrong. My answer has to be C. And I have methanoic acid there. So it's propanol and methanoic acid that I need, and that is C. Next, which statement about polychloroethene is correct? Polymer can be cracked to produce chlorinated alkene. That is right, because if you think about it, polychloroethene is formed from what? It's formed from chloroethene, which is this thing. And so obviously if you crack polychloroethene, which is this compound, then you will get this, right? Or things like that at the very least. So you'll get chlorinated alkenes for sure. And so my answer might be A. The polymer has harmless combustion products. No way, because you have Cl, so you can get HCl, which is definitely not harmless, is it? The polymer is ready to biodegradable when burned. No, because it's such a long chain thing that it takes a long time to degrade. Repeat, the polymer has an MR of 97. Let's see. So 2 carbon atoms means that the MR is 12 times 224 plus chlorine 35.5 plus 3 hydrogen atoms of 3, and then that makes 62.5. I got 62.5, which means it's definitely not 97. It's nowhere near 97, so the answer has to be A. Now, which row of the table is correct? Increasing number of carbon atoms. So now you just have to remember how should I do it? Meth, F, prop, but, pent. They've only gone to pent, right? There's 1, 2, 3, 4, 5. Just remember that, and it's simple addition basically here in this question. So 2 was ethyl, methanoate. So 2 plus 1 is 3. I'll just write down everywhere where there is ethyl. I'll just write down 3 because it makes the tabulation, the bookkeeping easier. Methyl propionate is 1 plus 3, 4. So 4, 4, 4, 4. And then you have whatever. Then you have propyl butanoate, which is 3 plus 4, which is 7. 7. 7. Right, and then you have pentyl pentanoate, which is 5 plus 5, which is 10. 10. I'm just writing down the number of carbon atoms there are in total, right? Including number of carbon atoms. Okay, so 3, 4, 10, 10 is, sorry, what? Why did I write 10 there? Propyl butanoate is 3 plus 7, right? 3, 4, 10, 7 is not an increasing number of carbon atoms. 3, 4, 7, 10 is an increasing number of carbon atoms. 4, 7, 3, 10 is not an increasing number of carbon atoms. 7, 3, 10, 4 is not an increasing number of carbon atoms. So my answer is B. Simple, easy, hopefully. And let's go to the next question. Which molecules have an overall dipole moment? Alright, so let's look at this. Carbon monoxide. Well, carbon is the electronegative one and this is the electropositive one. So should I say electropositive? Anyways, partially negative, partially positive. That's easier to think about it. So the net movement of electrons is towards oxygen, so that does have a dipole moment, doesn't it? You can see that from here. So there is a dipole moment here. All right, and then if I look at phosphine, which is pH3, so it's got a similar structure to ammonia. NH3, it's in group 5 as well, so it has a lone pair there, and so it's asymmetrical because of the lone pair. And since this is the electron partially negative one, these are the partially positive hydrogen atoms. So the this is going like this. If you have studied maths or physics and you know about mechanics, this would make a bit sense. But basically, you're having vector, things here, right? So over here, my dipole moment does not cancel out, does it? Because one is going like this and one is going like that, and I have one upwards. So I have a dipole moment. I suppose you could say it's upwards. The dipole moment, I don't know the exact direction of it, and I'm not bothering to calculate that in a chemistry paper. But yes, I do have a dipole moment here because there's electronegativity difference, and I have an asymmetrical molecule. Now, if I look at carbon dioxide, this is partially positive, this is partially negative, this is partially negative, and so I have, because it's a linear molecule, isn't it? As we mentioned before, it's sp 180 degrees, and it's so symmetrical, such a symmetrical molecule, and there's equal, the dipole moments cancel each other out, because over here I have a moment, over here I have an equal dipole moment, equal but opposite, so they cancel each other out, which means that this does not have an overall dipole moment, which means that my answer is B, 1 and 2. And now next, the diagram illustrates the enthalpy changes of a set of reactions. Which statements are correct? The enthalpy change for the transformation U to R is plus 42 kilojoules per mole. Let's check that out. This is my route. Now U to R, I'm going to use this route because I do not want to use this route because for that I don't have the value of T to R, which I could calculate using the other ones, but I'm just too lazy to do that. So I'm just going to go like this, right? Up and then left. So U to R, over here I'm going against the direction of the arrow, right? From U to S I'm going against the direction of the arrow we've drawn here, which means plus 92 would become minus 92. And then again here from S to R I'm going against the arrow, which means minus 134 will become plus 134. So if I put this in my calculator, 134 minus 92 should be plus 42. So I got plus 42 kilojoules per mole, which means 1 is right. Now if I look at the second option, the enthalpy change for the transformation T to S is endothermic. Is it? Let's again do the same thing and go with the arrows. So T to U and then U to S. So T to U I'm going in the direction of the arrow, which means I'll take it at minus 75. And then U to S I'm going against the direction of the arrow, which means plus 92 will become minus 92. And again, obviously this is very obviously a negative value. If you want to calculate it out, minus 75 minus 92 is minus 167. But you don't need to do that. It's quite obviously exothermic, because it's a negative value. So yeah, that is wrong, which means my answer must be D. But if you look at the last option, let's just, for the sake of it, just do it. The potential transformation R to T is minus 32. R to T means I'll go in this route one time. So R to S, S to U, and U to T. Right. So if I calculate this out, R to S is, I'm going with the direction of the arrow, so it's minus 134. And S to U, I'm going with the direction of the arrow again, so I'll just keep it as plus 92. And U to T, I'm going against the direction of the arrow, so minus 75 becomes plus 75. Alright, so minus 134 plus 92 plus 75 is plus 33 kilojoules per mole, in fact. And they have written it as minus 33 kilojoules per mole. That is obviously wrong, so my answer is D. Great. Next question. Which statements about reversible reactions are correct? So let me just write down a standard reversible reaction where I'm just writing variables A plus B, C plus D, right? The reversible reaction, and increasing concentration of a reactant always increases the concentration of product. That's quite obvious because imagine I increase the concentration of A plus B, any of A plus B or both of them collectively, you can take it as, the concentration is increased. So the equilibrium will try to oppose the change by shifting the, equilibrium to the right hand side, and by doing so, it will decrease the concentration of A plus B and increase the concentration of C plus D, and hence equilibrium will be re-established, right? So an increase in concentration of a reactant should always increase the concentration of the product, yes. An increase in temperature always increases the rate at which the equilibrium is established. Now the rate at which equilibrium is established should always increase by temperature, because temperature is, we're talking about temperature is a measure of, the average kinetic energy of the particles, right? And the average kinetic energy of the particles should increase when you increase the temperature, and so the rate does increase because the particles will have more kinetic energy, and so the collisions happen faster, blah blah blah. So that is right. They're talking about rate, remember. Now increase in temperature always increases the concentration of the product at equilibrium. Now that is wrong. Reason for that is because exo-endo scene, exo-endo wala scene. So you have, like, for example, if I take the forward reaction is exo, the backward reaction is endo. So if I increase the temperature here, my equilibrium will shift to the left hand side, because my backward reaction, or my this is endothermic, which means that because the equilibrium tries to oppose the increase in temperature, the change of increase in temperature, by absorbing the extra heat by favoring the endothermic reaction, which is my backward reaction here, which means that the product of C plus D, the concentration of product will decrease and the concentration of the reactants will increase. So that's what happens in this scenario. But if it was the reverse, where this is endo, this is exo, then yes, the concentration of product will increase. But this is not always true. Is it that it's always increased? No, that's wrong. So my answer has to be B. Just wanted to get correct. All right. A chemist. Let me just put my laptop in charge first. Question number 34. A chemist puts a sample of dilute aqueous hydrochloric acid into beaker 1. So you have HCl, which is dilute and aqueous as well. So she has a sample of zinc and measures the rate of production of hydrogen gas. So the reaction taking place, use right hydrogen and stupid of me, Zn. So ZnCl2 plus H2. It's 2Cl, okay? So now it's 2Cl. She then puts a different sample of aqueous hydrochloric acid into beaker 2. She has a different sample of zinc and measures the rate of production of hydrochloric acid. Now, we don't know how the samples are different. Different means it could be a different, I don't know, a different concentration, a different volume. It's different in some way, I mean. And then a different sample of zinc. A different sample of zinc could mean, I don't know, what comes to mind is a different mass, or maybe it could be a different size of particles, like maybe one has crushed particles and another has big particles, big pieces of particles. So that could be different, but we don't know the exact difference. And she measures the rate of production. Now, the rate of the reaction in beaker 2 is greater than the rate of reaction in beaker 1. Okay, very interesting. Now, what factors could help us make this observation? The reaction in beaker 1 has a higher activation energy than the reaction in beaker 2. I don't remember any mention in this question of activation energy being different. Activation energy will be different if you've added a catalyst or something, and no catalyst was added, right? They never mentioned the catalyst at all. So I would say that the answer is maybe C, because 2 and 3 are right. So if 1 is wrong, but let's just check it out. The zinc in beaker 1 is in larger pieces than the zinc in beaker 2. That's right, because if the zinc in beaker 1 is in larger pieces, then that means zinc in beaker 2 is in smaller pieces, which means the smaller pieces have the same surface area, like you have the same mass of the particles, but your surface area is greater, right? Surface area is greater in beaker 2, which means, because they're crushed particles, for example, which means that the rate of reaction is greater in beaker 2, right? Acid in beaker 1 is at a lower concentration than acid in beaker 2. Yeah, obviously, if the acid concentration in beaker 2 is greater, then there's going to be a greater rate of reaction, isn't there? And that's obvious from your, IGCSE chemistry, if you remember. So your answer is C. Now, in some rice-growing parts of the world, farmers use a combination of paddy fields and a fish farm. Rice paddy fields are flooded for much of the growing cycle, and water running off the fields flows through pens where fish are raised. Nitrogen-based fertilizers are generally soluble in water, which products could result from farmers applying excess nitrogen-based fertilizers to rice fields. So basically, they're talking about eutrophication, So eutrophication decreased fish production, that is right. Decreased levels of oxygen in water, right. And increased growth of algae in the fish pens is right. Why? Because of what happens in eutrophication, like you have excess nitrogen, so nitrogen seeps into the water body, whatever it is, a river or a stream or whatever it is, and so your algae growth increases in that river, and so a very thick algae layer forms rather than thin layer that there was before. You get a thick layer of algae, and since you have a thick layer of algae, now sunlight has stopped reaching to the bottom of the ocean, and so your plants and animals in the ocean, they start dying out because plants are unable to photosynthesize, for example, and stuff like that. So plants and animals die out without access to sunlight because of that thick algae layer, right? And so because they have died out, your anaerobic bacteria, your aerobic bacteria, which means that the bacteria that use oxygen to respire, they decompose the dead plants and animals, and so by doing that they use up the oxygen that's left over in the water, right? And since they've used up the oxygen that's left over in the water, even more plants and animals die out, which means that basically you've created a dead ecosystem now, and everything is just dead in the ecosystem, and that's, rest in peace to the ecosystem. But all of this happens: decreased levels of oxygen, decreased fish production, increased growth of algae, right? So that's all right. Now, a sample containing 0.40 moles of calcium nitrate was decomposed by heating in a roaring Bunsen burner frame. I love the word roaring Bunsen burner frame. A phrase, roaring Bunsen burner. Actually, there was no further decomposition. Until there was no further decomposition means complete decomposition, right? So that means all of your 0.40 moles of calcium nitrate were converted to the products of decomposition, which I'm going to write down here: CaO plus NO2 plus O2, and let's balance this out. So how to balance it out? You have 2 nitrogen, so 2 NO2, and then G2, there's 6, so 4 here, 5, 6. Let me just make it 1 by 2. Alright, so this is how to balance the equation out. And now if you have 0.40 moles of this, it should decompose into 0.40 moles of this, and the 0.40 times 2, so 0.80 moles of this, and 0.40 divided by 2, so 0.20 moles of this, right? Now, 0.40 moles of calcium oxide, that's right, I've mentioned here. 0.40, you don't even get nitrogen, bro. And 0.40 moles of oxygen, no, you get 0.20, so that's wrong, and my answer is D. Done. Easy. And, which reagents, when used in an excess, can be used to make sodium lactate, CH3CHOH, COO, and A from lactic acid, CH3CHOH, COOH. So let me draw out lactic acid first of all, which has 3 carbon atoms in the main chain. parent carbon chain, I mean COOH, and you have an OH here. All right, so I want to make CH3, CS, whatever that is. I'll just draw it out. Sodium lactate. Okay, so whatever it's called. I don't care about names much. All the names are very important actually. You should know how to name organic compounds. But I right now in paper 170, I just really don't care about names that much. Alright. So here I want this to be replaced by sodium, but I do not want my OH group to change at all, which means I cannot use sodium because sodium will react with both the OH from both the COOH group as well as the OH group, right? So it's become ONA here and ONA here as well, which I don't want one. So my answer is immediately C because 1 is out. So that means my answer is immediately 2 and 3, but let me just check. NaSCO3 and NaOH, both of them will react with COOH to give you COONA. So that's right, and they will not do anything to the OH group here. So that is right. So your answer is C. Alright. Now, chlorine atoms in the upper atmosphere cause the breakdown of ozone, and why is that? Is because of the chlorine free radicals that you get, right? Free radicals are very reactive, as we know. Now, which statement and how are free radicals formed? They're formed from homolytic fission, right? So, which statements are correct when referring to these chlorine atoms? The chlorine atom is excellent catalyst. Well, here I have chlorine and here I have chlorine, so by the end of the two reactions, this remained unchanged, so that's right. The chlorine atoms are free radicals, as I mentioned. Yes, they are. Chlorine atoms are formed by heterolytic fission. No, they're formed by homolytic fission, as I also mentioned. So for covalent bond in chlorofluorocarbons, so my answer is B. An unknown organic compound, so number 39. An unknown organic compound C reacts with sodium to give a combustible gas one product, and I would be smart to assume that it's H2, okay, because that is, you get, I have a lot of chemistry questions and chemistry stuff. Get sort of chemist's intuition, obviously it's in page 2, okay? So Z does not give a yellow precipitate with the alkaline aqueous iodine, which means it doesn't have the group COCH3, right? So it's, this group is the one that gives a positive test for alkaline with alkaline aqueous iodine, because that will give you whatever it is. I have to revise this reaction actually. I don't remember the name of the thing. It's called chloroform or something. No, not chloroform. Iodoform, right? That's what I meant. Yeah, iodoform. So what is the possible identity of C? So let me see. But first I'll check out ethanoic acid. Ethanoic acid, whatever you want to call it, ethanoic or ethanoic, whatever pronunciation is. So that will give me, that will react with sodium to give me ONA. That's right. So, and that that becomes half H2. The reaction. So that could be possible. And does it give a yellow precipitate with alkaline aqueous iodine? No, it doesn't. It doesn't. So this is right actually. This could be a possible identity of Z. Now let's check out pentane 3-ol. Okay, let's check out pentane 3-ol. So 1, 2, 3, 4, 5 carbon atoms, and then over here OH. Obviously, because OH will react with sodium, so you get Na, and then you will get hydrogen gas. So that is the first part of the thing is right. And now it does not give a yellow precipitate alkaline aqueous iodine. Yes, it does not give, because over here it has a ethyl group, over here it has the ethyl group. It doesn't have any methyl group, so it's not possible that it gives iodoform test. So this is right. But propane 1-ol. Propane 1-ol, but again, because it has OH, so it'll give ONA with H2. And so the first part of the thing is right. And the second part does not give a yellow precipitate alkaline aqueous iodine. Again, it has it has ethyl group here, right? So that means that, or should I say, whatever. The point is that it does not have a methyl group, or like it doesn't have COCH3 or even COCH3. It doesn't have any of those. So that means it cannot give a yellow precipitate with alkaline aqueous iodine, which means that it satisfies both the conditions for this question, which means that it is also a viable option. And so your answer is A. Last question. Compound X has the molecular formula C3H6O3. Beautiful. Heating X under reflux with, so let me just take a random X, and heating X under reflux, so plus K2Cr2O7, that is acidified, forms what? It forms 3-carbon thingy, which has OH here, C double bond OH, and it's COOH, carboxylate group, right? And then you have a CO as well, so you get that, okay? And then reacting X with NaBH4, so plus NaBH4, which is a reducing agent. So that since it's a reducing agent, right? That's an oxidizing thing, and since reducing agent, so we get what you get. You get OH, and you get OH, and you get OH here as well, right? So that's what you get with NaBH4. And NaBH4 is a weak reducing agent. Keep that in mind. So yeah. Now, what is the possible structure formula for X? Let's see. Good. Number one is what? OH, and there is one OH, and that has one OH here, and that's the structure of number one. But the problem with number one is I don't have any oxygen here, so how would this form? And moreover, NaBH4 cannot reduce carboxyl group, so that cannot form either. So one is definitely out, which means my answer must be C. But let me try out 1 and 2 first before assuming that C is the answer. Try out 2 and 3. So 1, 2, 3 carbon atoms, and I have there and a O here, OH in fact, yeah, and OH there. So could this form? Well, yes, it could be oxidized to that, and this could be oxidized to that, and that's, yeah, because this part of the react this oxidation wala thing is right. And what about this one? Aldehyde could be reduced to OH easily by NaBH4, and then OH already OH. It's fine. So yes, 2 is right. And what about C? Let's see. Let's see. No, that sounds funny. Anyways, OH, and then I have CO. So CO remains CO after oxidation, and then OH and OH are both oxidized to carboxyl. That's right. And then with the NaBH4, you could reduce the ketone to secondary alcohol. That is also right. So that means my answer, that is the answer C, is also right. And I mean, the answer option 2 and 3 are both right. So that means 1 is wrong and 2 and 3 are right, which means my answer is C. And look at that, we are done with the paper. And am I not glad? It was quite a fun paper, honestly. A beautiful paper. I love paper 1 more than paper 2, 3, 4, because it's like MCQs. You don't need to write stuff. I don't have such good handwriting actually, so paper 1 is good for me. But you have to, when you enter the exam hall, you get a bubble sheet, and you do have to fill that in carefully. But my favorite paper is paper 1. So yeah, I hope you all enjoyed that and that was of benefit. And yes, thank you for listening, and have a nice day, and good luck with your, I mean to say, I shouldn't say good luck, I should say all the best for your exam. So yeah.